Hello everyone, welcome to Elevate Techie Data Science series. Today we are demystifying the process of selecting the performance measures for our ML model. Choosing the right metrics is having a compass on our data exploration journey. So let's dive in. The first step of selecting the performance measure for any model is understanding the nature of our problem. So before selecting the metrics, we need to understand the nature of our problem which we are trying to solve. Is it a classification task or a regression task or something else? This foundational knowledge helps tailor our performance evaluation. Based on the task, we have a different types of performance measure in ML. So let's see what are the common classification metrics we can choose. So for classification tasks, common metrics can be accuracy, precision, recall, F1 score, confusion matrix, ROC curve, and so on. Starting with the most intuitive metrics, we have accuracy. So it tells us the percentage of correctly classified instances. While easy to interpret, accuracy might be misleading in imbalanced data sets. For a scenario where one class significantly outnumbers the other. Next, we have the precision. Precision is number of true positives divided by the sum of true positives and the false negatives. It tells us accuracy of the positive predictions. Next we have recall. So recall is number of the true positives divided by the sum of the true positives and the false negatives. It measures how well our model captures all the positive instances. Later we have F1 score. Now let's talk about F1 score. It is the harmonic mean of the precision and the recall, offering a balanced measure. F1 score is particularly useful when we need to consider both false positives and the false negatives in our evaluation. Now let's look into confusion matrix. So this matrix breaks down true positives, true negatives, false positives and the false negatives. It's a powerful tool to understand where our model excels and where it might need improvement. And later we have the ROC curve, which means the receiver operating characteristic curve. For binary classification, consider a ROC curve. It plots the true positive rate against the false positive rate at various thresholds, helping us to assess the trade-off between the sensitivity and the specificity. Lastly, we have area under the curve, which is area under ROC curve. It provides a single value that summarizes the performance across different classification thresholds. A higher AUC ROC indicates a better model performance. Now let's bring this to life with a real world example. Suppose we are predicting whether an email is a spam or a ham. Will we prioritize catching all the spam, or is it more crucial to avoid classifying non-spam emails as spam, which has precision? And here our choice guides our metrics. Now let's look into the regression metrics we considered for the model evaluation. First up we have the MSE, which means mean squared error. And this is a popular metric which calculates the average squared difference between the predicted and the actual values. And it analyzes the large errors more, providing a comprehensive view of overall model's performance. Next we have the MAE, which means mean absolute error. Unlike a mean squared error, mean absolute error takes the average of absolute difference between the predicted and the actual values. It's more robust to outliers and offers a straightforward interpretation of the average error magnitude. Next, let's talk about R squared. This matrix measures the proportion of variance in dependent variable that is predictable from the independent variable. In simpler terms, it tells us how well the model explains the variability in data. So these are the most commonly used regression metrics for the model performance evaluation. So below are the few points which we need to keep in mind while selecting the performance measures for our model. The first is choosing the metrics based on our goal. So we have to select the metrics which are aligned with our project goal. If we are trying to build a medical diagnosis model, high recall might be crucial to catch as many positives as possible, even if it means more false positives. Also, it is a balancing act that we need to consider in our mind. No single metrics fits all the scenarios. So we have to consider the trade-off between the precision and recall or other conflicting goals based on our project requirements. And in case of imbalanced data sets, which means basically one class significantly outnumbers the other, accuracy alone might be misleading. So we have to look into the different metrics like precision and recall, which will focus on model's performance with respect to the specific classes. Next point to consider while selecting the performance measures for the model is domain specific considerations. Sometimes a specific metric might be more relevant based on the application. So, for instance, in healthcare, specificity and sensitivity are more crucial. So, these are all the points which we need to keep in mind while selecting the performance measures for the model. So, in today's video, we have seen what are the different performance measures available based on the task, which is regression task or a classification task. And also, we have looked into the points which we need to keep in mind while selecting the performance measures for any model. So that's all for this today's video. And if you like this video, don't forget to give it a thumbs up and subscribe to my channel for more content on ML and data science. Thank you for watching the video and I'll see you in next video guys.